All right, we're going to go through how to design a rocket in the rocket simulation software called Open Rocket. So if you don't have the software yet, you can do a Google search for Open Rocket. And the first link here is openrocket.sourceforge.net. And then come over here and click on Download Now. And it will take you to a download page. And it says the download will start in just a few seconds. I've already downloaded it, so I'm going to cancel the download. Once it's downloaded, you can open it. It's possible that you'll need to install Java on your computer if you don't already have it. So do a Google search for Java and then click on the first link here, download free Java software, and click on there. So once you have it installed, you can open it on your computer. And your home screen should look like this. We're ready to design our rocket. So we're going to design a rocket based on the Alpha rocket. So we'll go through each step of adding each component. So first we'll click on nose cone. We'll want to add a nose cone. You should measure the length and diameter of your nose cone. And you can also click up here and hit select preset from database. I'm not sure exactly which nose cone is on the Alpha, but I know that it goes with BT50 body tube, and I also know that it's plastic. So we'll see here we want one of the plastic nose cones by Estes, and we'll choose this one, PNC50, because it goes with the body tube that we have, which is a BT50. So we'll click OK for that one, and you can adjust the lengths if it needs to be a little bit shorter. You can do this, and then we can close that. So now we have our nose cone. The next component is our body tube. So we have a body tube that was selected that fits with our nose cone, and you'll want to measure your body tube and make sure that it is the right length. So maybe you measure your body tube and it's 18 centimeters, so you want to decrease it to 18 centimeters. And our body tube is cardboard, so we can click close that. So now we have our nose cone and our body tube. And the next thing we need are fins. So and a launch lug. So if we click on the body tube here, it allows us to add these things. If the body tube's not selected, you can't choose the fins. So we'll click on the body tube, and then we have trapezoidal fins. So we'll click on this. And what's helpful is to be able to see the fins while you're changing the values here. So you can start by, you should actually measure your fins and see how long is this section. This is called the root chord. So if I make this smaller, it makes that smaller. So maybe your root chord is 5 centimeters. And then our tip chord is this distance here. We'll reduce that a little bit. There we go, to 2 centimeters. And then what you'll want to do to get them angled further down is increase the sweep angle here, like this. You can also just measure the sweep length. That's this distance here. So you can increase our sweep angle till it models the fins that you have pretty well. And we want 3 fins, so 3 is selected up here. And once that's finished, you can click on close. Oh, actually, our fins are not cardboard. We want to change this material. Our fins are balsa wood. Here we go. Balsa. And then we close. This just changes the weight, or the mass. Okay, so now our rocket's looking a lot like it should. And then we'll click on the body tube again, and we need to add a launch lug. So click on the launch lug, and our outer diameter of our launch lug will just be, we'll go to inches, it'll be an eighth of an inch. That's 0.125. Okay, and then we'll close. Now, up in this section here, you can change what view you're using. So we're going to go from side view to back view. And notice that your launch lug is in line with your fins. This is a problem for launching. So we'll go up into this area and click on launch lug, double click actually, and we'll change the radial position of the launch lug. You can actually go up. Let's make it rotate at 30 degrees. And that should be fine. Now we can close it. So now our launch lug is in a good position. It can be anywhere along here as long as it's not in line with the fin. Then we'll go back over here, change it back to side view. So now we have all of the outer components of our rocket set up, and now we're going to add some of the inner components. We'll need to add an inner tube that goes inside this rocket for our motor. So we'll call the motor tube. So once the body tube is selected, we'll click on inner tube, and what we'll want to add here is we'll want to choose we'll go to Estes here, and then we want to choose a BT20 body tube. That's what holds the A, B, and C motors that we'll be using on this first rocket. Okay, now obviously it's way too long, so we only want it to be maybe a few inches here. So let's see what 10 centimeters looks like. Okay, it's a little too long. You should actually measure this tube, make sure that you have exactly the right length, and then this allows us, says position relative to bottom of the component. You can change where it is in the rocket. I think we want it about half a centimeter poking out at the bottom there. Maybe we'll do a full centimeter. Okay, and then we can click on motor and select this component is a motor mount. Okay, and our motor overhang is going to be another centimeter. Well, if our motor overhang is a centimeter, let's go back here and just make this be right in line like that. Okay, so now we're ready to add a motor later. We'll select our body tube now. We'll need to add a centering ring that holds this tube in place. So click on centering ring. We'll want the ring. Sorry, hold on. Let's just confirm. Our inner diameter of this is 2.08 centimeters. So we'll want our centering ring to have an outer diameter of 2.08, and its inner diameter is 1.87. It looks like it set it correctly for us. The inner tube, yeah, 1.87. So our centering ring is all set, but we don't want it to be here. We want it to be in the middle here. So we'll double click on our centering ring. We will increase our thickness a little bit. You should measure the thickness of it, and then we're going to adjust its position here like that. And then it's made out of cardboard, so we're good, and we'll close that. So everything is looking good so far. The only thing we need to add is our recovery system and our shock cord. So we'll be using a parachute for this, and 30 centimeters is about right. It's about 12 inches, which is what our parachute will be. I like to change the packed diameter just down a little bit smaller. So see where it is here. That way it clearly fits inside the tube. And then I'm going to adjust its position again, position relative to the top of the component, so that it's in the actual rocket here. And then close, and now I'm going to add my shock cord. This is what attaches the nose cone to the body tube. Again, I'm going to reduce my packed diameter. This length is fine for the shock cord, and then we'll just move it over here. They'll both be pretty much in the same area inside the rocket. And then we can close. And then the only other thing is we'll have a little bit of wadding in here. It's not necessary to add that because it has almost no mass. You can notice here we have this little symbol and this symbol, and the one that's blue and white is called the center of gravity, and the red dot is the center of pressure. We want to make sure that the center of gravity of the rocket is always in front of the center of pressure. Otherwise, the rocket will not be considered stable, which is a requirement for it to be able to fly successfully. Now we can go to the next section, which is motors and configuration. So we'll select this and click New Configuration. And it adds a new configuration here. And then we'll double click on this, and now we'll select our motor. The motor that we want to select is we'll do it with a B6-4, so a B engine, and then a C engine. A B6-4 has 6 Newton-seconds of force and a 4-second delay. So we'll choose the B6 engine, and then we'll come up here and you can actually choose different delays, but we'll choose the 4-second delay. And then we'll hit OK. Notice that as soon as we add our engine, it then tells us some data about the rocket's flight. The apogee is its maximum altitude, and then we have its maximum velocity or speed and its maximum acceleration. We're going to add one more motor so that we can run both simulations. So we'll click New Configuration, double click here, and we'll choose a C engine. And for the C engine, we want a 5-second delay. So after the engine burns, it then waits 5 seconds before the ejection charge explodes or goes off. Okay, so we've chosen that engine as well. Notice that the maximum altitude is higher, called the apogee, with the C65 engine because it's a stronger, a more powerful engine. Now I'll go over to flight simulations here. We'll choose the first one with the B6-4 engine, and we'll hit Run Simulation. So it ran the simulation, and it tells us all of these different attributes of our rocket. And if we come over here, we can click Plot, and then down here, click Plot, and it shows us what's happening on the flight of this rocket. And two of the most important parts here are these two lines. One is when the recovery device is deployed, and the other is the apogee, the maximum altitude. Ideally, we want the recovery device deployment a little bit after the apogee, or right at the apogee. If the recovery device comes out way before, when the rocket is still going into the sky at high speed, then it can damage the recovery device or the rocket. So this one, it plots the altitude, which is in red. So the altitude goes up to a little bit like 170 meters, and then it slowly comes down with the parachute, and it should be up and down in about 51 seconds. Now we'll do the same thing with the C65. We'll click on that and hit Run Simulation, and then we'll click Plot, Export, and Plot, and now we can see what's expected to happen. It goes up to a little more than 300 meters. The recovery device deploys, and then it slowly comes down, and it's down in a little over 90 seconds. So this is a much longer flight in the air. And you'll see too here that it takes off. The greenish yellow is the velocity, so it has a really high velocity, and then it only burns for about a second and a half, and then the motor, it says motor burnout, so the motor stops, and then we have a 5-second delay. 1, 2, 3, 4, 5, and then the ejection charge goes, and the nose cone comes off, and the parachute comes out, and the rocket comes to slowly falls to the ground. Okay, so this is how you model and simulate a rocket. One addition that we're going to be exploring, if we go back to rocket design, is adding a payload section. So payload section, if we come up here, we want to add another little section of body tube. We want our body tube to be shorter in length, maybe only 4 inches, and we'll close. And we don't want it to be behind here, we want it to be up here. So if you go up here, you can drag it and move it up in front like that. And this will be our payload section where we store the altimeter. And we'll need to add a coupler that we'll use to connect this body tube to this body tube. And again, we don't need it to be quite this long. That should be fine, and then we'll want to move it 1 centimeter down so that it can attach, and it can be glued here and then just have a friction fit here. Okay, and then we'll have to add our altimeter and a shock cord into this body tube. So for shock cord, we already know how to do that. And then we'll move it back a little bit. And then for the altimeter, we'll just have to add a mass object and mass component, and we can select altimeter, and the altimeter mass is about 7 grams, so we'll do that, and the diameter is a little bit smaller. We'll move it back, and we can even name it up here altimeter, and then close. And now we have our payload section, and we can go back to our flight simulations and rerun this simulation, and it updates the numbers. We can plot it again and see exactly what's happening. So now it goes up and comes down in a little bit less time. You'll notice here that the apogee changed because the rocket has more mass now. And then we can do the same thing. So see the maximum altitude, the apogee is 300 meters. And then if we run the simulation with our new design, it's only 245 because we've added this additional component to our rocket. Alright, that should be it, and good luck designing and simulating your rockets. We'll be taking screenshots of the rockets as well as the simulation data, so as well as pictures of this, and using those on our pre-launch reports.